This is number 23, lesson 3.8. So you got a particle. It's moving along a line. It's moving along the x-axis. So let's say this is the x-axis. Let's say this is 0. Got some particle moving back and forth on the x-axis. Okay? Its position is given by this. Its x-coordinate is the arctangent of t. T is time. So at any given time, you can find out its position. That is a fancy way of writing inverse tangent of t. Arctangent and inverse tangent mean the same thing. So the first thing they ask you to do on this one is to prove the particle is always moving to the right. So if it's always moving right, what's that tell you about the velocity? It's positive, yeah. So what we need to show that the velocity is always greater than 0. Now, how do I, if this is the position graph, how do I find the velocity? You have to do the derivative. Yep, so you're going to have to do x prime. You have to show that x prime is positive or greater than 0. So how do I find the derivative of that? Well, that's flip your sheet over, flip your formula sheet over. That's where all these formulas come into play. Now, of course, you could make the calculator do the derivative for you using numerical derivative. But instead, we're going to go to the back side. I want you to look at formula B. Formula B on the back side says the derivative of inverse tangent of u, they're using a u instead of an x, is 1 over 1 plus u squared times du over dx. So what I'm saying here, what that formula is telling me, if I want to know the derivative of this, I just take 1 over 1 plus, instead of u, we're going to use a t here, t squared, times the derivative of t, which would just be 1. Now, think about the denominator here. Is there any way that this expression could ever be negative? No, when you square a number, you get a positive, don't you? And then you add 1, that's still positive. 1 divided by positive times another, that's always going to be positive. So I'm going to just finish this up. X prime is, since the velocity equation is positive for all values of t, the particle always moves right. Right, remember that when you have a particle moving on a horizontal line, positive velocity means moving right, negative velocity means moving left. Any questions about part A?
What is the dt over dx for?
I'll shut this off here for a second. Well, let me talk about how to do part B, then I'll shut that off and we can go through that with you. So we'll keep the video somewhat short. B. Prove the particle is always decelerating. If it's decelerating, that means what?
Slowing down.
Okay. How do I find acceleration? All right, so you're going to have to do x double prime. So you're going to have to, if it's decelerating, you're going to have to show that x double prime is less than 0. Okay? To show that it's always decelerating. You're going to show that the derivative of this expression will always be a negative number. So what rule are you going to have to use to do the derivative of that? Quotient rule, yeah. So you do the quotient rule, show that that's always negative.
Couldn't you use the velocity formula to prove that also, since the bigger t gets, the lower velocity will be? Because velocity would just keep approaching 0 then.
That's true. He's saying as t gets bigger, this answer is going to get smaller. So as t gets larger, the velocity is getting smaller, so it would be decelerating. That'd be another way to do it. You're right. Okay, good. kind of thinking outside of the box, a calculus guy would always think, okay, decelerating, I go second derivative. But you could also look at the first derivative and think that it's getting smaller. That's a good point, Mike.